I said, we ignored water. The K for HCl, and it's not a weak acid, so it's a really large number. It's about 10 to the 8th or 10 to the 9th. It's a really big number. So that's the one we do first. And so we say HCl plus H2O, CO minus. So this was 10 to the minus 8th. Strong acid, it dissociates completely, so this is about 10 to the minus 8th, which is what we said. Then we do OH minus. And we say, this is, and I'm just going to do the C because this is, no, I don't want to do the C. I have to do the I. Sorry. Why do I have to do the I? Because this is 10 to the minus 8 from the HCl. Question?
You know what the hydrogen 10 to the minus 8 came from?
This K is fake.
No, that the
Oh, the problem was,
the
I have a
hydrogen
10 to the minus 8 molar HCl solution. What is its pH?
Yeah.
That was the problem from a long time ago. And I said, think about it when you go home. And I said, the clue is you ignored, you want to think about what happens with the water. And then the next day when we came back, it was after the weekend, I said, how many people thought about it? And everybody said, thought about what? That sort of thing. Okay? And so I asked a couple days ago, and people still didn't think about it, so I gave you the answer. But now I'm going to show you where I got the answer. And so what I have is this is I, this is 0, minus x here, if I were to do that, plus x, that's the dissociation of water. And now I have the concentration, hydrogen, concentration of hydroxide X, and I say Kw is X. And I said you could do this by approximation, and I said it would take you about 10 steps because it doesn't converge very rapidly. So what I did here, and the only reason I'm doing this is because I finally remember my book where I did it once. I expanded it up, and I got 0 is equal to 10 to the 2 plus 10 to the 8th x minus 1 times 10 to the minus 14th. I put it in quadratic form, and then I plugged it into the quadratic equation. And the two roots from the quadratic equation, in other words, I did that minus b plus or minus square root b squared. Actually, I didn't do it. I had it programmed into one of my other calculators, and I plugged it in there. And that's why this calculator, every time I program it in, somewhere I erase it. It's not there anymore. So, and you have to do an equation solver. Because we don't use it that often. Okay? So basically, one of the roots, x1, equals minus 1.05 times 10 to the minus 7. And that's weird, because that means what? You had a negative amount of hydroxide ion. So that can't be the right root. That's what I said. When you're doing these things, you get two different answers, one of them that makes sense and one doesn't. If you have a negative number for x and you started with 0, that means you have less than 0 amount of hydroxide. And what did I say? I say this to my A students. I don't know if I said this. I said it this semester also. You can't have less than 0 amount of anything. We don't have negative grams of something. Only in science fiction maybe you have negative matter. But this is in a science fiction class. Okay? So the other root, and I put my glasses on because it makes the right smaller, is 9.51. That's from the quadratic equation. And from the minus 8. So this is the hydrogen ion from water. In other words, that's what X is. And now I add 1 times 10 to the minus 8 to this. So I get my total hydrogen ion from this line right here. I did the addition on my calculator. I think I can do it in my head too. But that's the hydrogen ion total, and now that gives me a pH of 6.98. It's not pH 8, it's 6.98, which is slightly acidic, yes?
Okay, when HCl dissociates, I don't know where you got the molarity for the hydronium.
Because I said we started with what?
-8 molar HCl.
10 to the minus 8 molar HCl, that was the problem. And so what is the pH of a solution that is 10 to the minus 8 molar in hydrochloric acid? Okay. And hydrochloric acid is what type of acid? Strong. That means it dissociates completely. So this is now 0 after it dissociates. It can't be really 0, that's because it's always in equilibrium. But this is mostly 10 to the minus 8. So that's where that was the original problem. Okay. And so the trick is, I was trying to point out, you can't dilute an acid enough to make it basic. So if you do the simple thing, you would say pH is 8. pH 8 means it's a basic solution, so you can't do the simple thing. So now you have to do the common ion problem again. It was a common ion problem. I said I wouldn't say, I'd save those till last. Okay? Now, somebody said, let's do another common ion problem. What? You didn't like the ones I had so far. So let's try something different.